Okay, like they're complex. There's a lot of polyatomic ions to be that get involved, but specifically ionics are going to be metals and nonmetals, or metals and polys, or polys and polys, right? Ions and ions and ions, oh my. But then you've got covalent ones, which are pretty easily identified because what do they have in them? They have, okay, in the name they have prefixes, right? But in their symbols, in their non-metal, right? So the first one, guys, what is this? Covalent or ionic? Okay, everybody should be with me, right? Everybody's with me. This is sulfur and oxygen, so we say those are two nonmetals, so it's definitely covalent. So I don't need to look at the periodic table at all. I don't need to pull charges. I don't need to crisscross anything. It is what it is. I see sulfur, I write sulfur. I see oxygen, but it says trioxide. So what do I have? O3. Okay, so is this binary ionic, binary molecular, or ternary? Binary molecular. Molecular means covalent. There are two nonmetals which would indicate to us it's covalent. Okay, next I see iron 3 carbonate. There are three things there that would give me indication that this is ionic or covalent, sorry. Ionic, right? So the first thing I see is, oh, carbonate. So you see the 8 ending, so you're like, I already know that's a what? That's a poly, right? Second thing it shows you is iron, which is a metal, and then it's already here showing us a 3. Well, why would I need to say 3? That's the charge of iron. So there are three things there that are definite giveaways that this thing is ionic. So then I have to pull this together by doing what? What rule? Crisscross charge rule, right? So what's iron symbol? And what is its charge? 3 plus. Rainier, just get with me. Okay. And then everybody, what's carbonate? Try not to look at your list where you can't, okay? CO3 parentheses 2 minus. And when you crisscross it, what do you get? Fe2 parentheses CO3 3. Good. So the 3 goes on the outside. Is this binary ionic or ternary? Ternary, because ternary means more than 2 elements involved. There's iron, there's carbon, and there's oxygen. Okay. Next one, ionic or covalent? Loud and proud. First of all, units ionic is what do you see? What do you see initially? No, the bromide, that's a nonmetal. That could be with ionic or covalent. So that doesn't give you a helpful guide. Everybody sees what? Barium. Barium is in group 2, so that's a metal. So we know we have to do what to make this formula happen? Crisscross charges. So I've got to graph charges now, right? So barium's charge is what? 2 what? 2 plus, because it's in group 2, so it loses 2 valence electrons, gaining, or overall attaining a cationic charge. Maverick's table, tell me bromide. Br what? 1 minus, right? So give me the charge as it's intended to be said. And then give me the full compound, guys. Sorry, I'm asking this table. BaBr2, and that is barium bromide. Good. So when we see ide, you saw ide up here, and you saw ide down here. Does ide tell you if it's ionic or covalent? Yeah or nay? No, ide is across the board, right? It's an ionic and covalent. Ide just tells us what? It's just an element from the periodic table. You take that thing down, you put it in your formula. There were crisscross charges with it. So ides are going to be everywhere. That does not help you determine if it's ionic or covalent. It's all the other junk there, okay? Bailey's table, get me started on 10,2 fluoride. Ionic or covalent? How do you know it's ionic? So 10 is a metal, and it gives us this charge thing, right? Okay, so tell me give me the starting points. Sn 2 plus and not FL, but just F here. F 1 minus crisscross. What do you get? SnF2. Good. And we say this. Oh, sorry. This one was binary ionic, and this one is what? Binary ionic. Okay. CJ's table. Magnesium oxide. Get me started at either ionic or covalent. How do you know it's ionic? There we go. Okay, so we know one metal is there. It's going to be ionic. Get me started on, what would come next. And, okay, so that's in group 2 and group 6. Crisscross, what do you get? Good, so everybody at first would probably write or think Mg2, because that 2 crosses in, O2, because the 2 crosses over. but then we must reduce these both down to the simplest ratio of 1 to 1, which would be magnesium, or MgO, magnesium oxide. All right, how are we doing so far? Bringing it back some, okay. I'm going to do a couple more with you. I'm going to let you guys start, though. I want the formulas for these 5. If you can avoid looking at your poly list, that would be very good. I would have a periodic table out in front of you so you can keep having that reference as a guide. And if you use the same one over and over again, then, you know, you start to remember things are a little better. All right, come back to me. Menu's table, get me started on number 1. Give me the formula. Menu's table.
Silver for it would be, you have S silver. And then 2 atoms for short.
So let's go through the process again. So everybody has to make sure we're on the same page. We always have to identify if it's ionic or covalent first. Everybody, ionic or covalent for this one. How do we know it's covalent? 2 nonmetals. Okay, start back with you. It's covalent. Do you say anything about charges for covalent? Not at all, right? So covalent all the way, and then get me started.
US, F, 6.
6. Hexa means 6, right? So remember 6 has an X in it, hexa has an X in it, so that's going to help you remember that. 6. Moving on. Kendall's table, aluminum acetate, ionic or covalent? Ionic, okay, so then get me started on how to approach this. Okay. Good. So you probably heard her say, she didn't say parentheses, but she paused, which kind of helped us see like that was a gap, and then we put the 3 on the end. Jacob's table, diphosphorus, monosulfide, diphosphorus monosulfide. Ionic or covalent, sorry.
Covalent.
How do you know it's covalent?
Because it's metals.
Okay, and then so you break off on that side of your brain, and what do you say?
Phosphorus, P2, and then
S. Thank you. Potassium nitrite, Ryan's table. Ionic or covalent?
ionic.
How do you know it's ionic? How do you know it's a poly? Well, it's a metal and not a non-metal. It's a metal and a polyatomic ion, like you said, but how do you know it's a polyatomic ion? Because that's a metal. We got that much. Elizabeth. Yeah, ite means 8 and ites are both very common in polyatomic ions. Good. So there are 2 indicators there. Okay, keep going. Potassium is what?
K.
K. Give me the thing that goes with it. It's in group 1, so does it gain or lose an electron? 1 plus, okay. Somebody else? So, no, nitrate is NO3 1 minus, so nitrite must be what? NO2. Remember when we go from 8 to 8, what do we do with our O's? You lose 1. Okay, so NO2 1 minus. Okay, crisscross K NO2 because the ones both are those ones. Aiden's table. Can you guys help me with ammonium chloride, ionic or covalent? Ionic. Sorry, I totally just used your table. Can you guys table pick up from here? So is ionic, so you're telling me the polyatomic ion of ammonium, right? So NH4 what? Plus 1. And then chloride? Okay, and so put that together, what do we get? NH4Cl. And I don't have to put the parentheses because there's ones there, there's no changing of the subscript at all. But if it helps you to see it better, I would keep your parentheses until you're very comfortable. Okay, so I wanted to review those kind of collectively so that you can see, one, there's a very, very high emphasis on covalent or ionics. Ions, they are predominantly what we see in our chemistry life. So you'll see those more often, especially like in a quiz situation. You'll see covalents as well, but those are your, easy peasy ones. I'm going to show you acids today. This will take us about 10 minutes. And with the acids, you'll then be able to complete your problem set. So I'm going to give you some time to, I need to see your problem sets a little bit more in detail, and then you can complete that. So going to acids, I first wanted, I'll show you that in a second. Let me go straight to acids. All right, so if you're interested, page 272 in your textbook is going to be a good resource for this. So write this down someplace, just so you know what page it is. And then pull out the acid notes, which are on the back side. The acid notes I provided you are on the back side, or the acid practice I provided you is on the back side of the big, huge table. It's like a front and back. So just find that for me because we eventually will be practicing off of this. It's not the crossword one, it's the other one. I gave you those 2 papers on Friday. Okay, so with acids, we will experience very similar things as we did in ionic. Ionics, they are binary ionic and ternary, right? Binary ionic means what? Just periodic table, like 1 metal and 1 non-metal. So basically 2 atoms, because binary means 2. Ternary means you got a what involved? A polyatomic ion. We have the exact same situation here. You have a binary acid and you have a ternary acid. So I'm going to let you first write down this information. I'm going to elaborate in a moment, but I want you to have a template down first. I was just telling you had some practice on yours. This is not where the notes are. We have practice. We're going to get on this in a second. So write your notes someplace so you're going to look at them. Alright, so here are your key signs. For acids, they act actually really similar to ionics, but they look a little different. So one thing we should know is that acids have a hydrogen in the front of the formula. So that is your dead giveaway, when you have a hydrogen in the front of the formula. Of course, that would be meaning I gave you the formula so you can see the H. So like here you can see the H, and here you can see the H. And those are like the most generic expressions for an acid. Otherwise, you know it's an acid because in the back side of the name it says acid. So dead giveaway, it's an acid. So you can see acid here, and I have acid here. So those are the two ways you look at a name and you know it's an acid. So if it is an acid, you have to actually crisscross charges, just like
Miss Enlow,
ionic. Yes.
do you have Ryan done?
Yes, ma'am.
Could you come to Miss Landon in S3, please?
Can you wait just a minute?
Yes,
Thank you.
thank you.
Okay, so you have to crisscross charges just like you would ionic. So you guys have all heard of this acid, hydrochloric acid. Who's ever heard of that? Where would you find it in your body? Stomach, right? Your stomach acid is hydrochloric acid. So when you hear hydrochloric acid, what elements are you hearing? Hydrogen and chlorine, right? So that word hydro does not mean acid. The word hydro does not mean hydrogen, it doesn't mean acid. The word hydro means that it's binary. So the word hydro does not tell you it's an H, it does not tell you it's an acid, it means it's a binary compound. So hydro, and when you hear chlor, you think chlorine, but we adjust the name to not be chlorine, but we name it chloric acid. So what two things are coming together here? Okay, what two ions? Remember, because we were crisscrossing charges. H, what group is it in? It's first group, so it must be plus 1, okay? Chlorine, Cl's, 1 minus, right? Crisscross charges, what do we get? HCl, right? So that's a pretty common one we've seen before. What if I give you the example of hydronitric acid? Okay, example, hydronitric acid. Deciding your group, what comes together? It's a formula. So we are not using polyatomics because we are not in polyatomic world yet. We are saying hydro, which means binary. So it's just going to be two nonmetals. Two nonmetals for us. All right, so what's the first element, guys? H what? H with the +1 charge, right? Because hydrogen, the acidic hydrogen always contains a 1+ charge. Nitric refers to nitrogen, which contains a 3-, so that's H+ and a 3N3- because it's in group 5. And what do we get when we crisscross? H3N. And that would be hydronitric acid. So we are crisscrossing charges. Okay? Now, we are also still crisscrossing charges with ternary, but what's one way that I'm going to tell you it's ternary when I say the name? I'm not going to say hydro. So remember, hydro means that acid is what? Binary, meaning element 1, element 2 crisscross charges. So if I don't say hydro and I still say acid, you're like, okay, I still have an H+ because it's an acid, but I can't say I can't say just a normal non-mel. It must be a polyatomic. So your polyatomic endings, darn it, they change. They're not 8s and X anymore. 8s and ites anymore. They're X and os. So the ending of 8 goes to ic acid, and the ending of ite goes to os acid. I know, another modification to the naming, and this is like the worst part, but I've got a little cheesy way to help you remember it. Ick, I ate too much. Ick and ate. And I've got so much chemistry homework. I've got tendinitis. Ick, I ate too much. I've got tendinitis. They both, come together. Anyway, okay. So if I tell you the name nitric acid, notice how similar this one is to that one. That was hydronitric, and this is just nitric acid. So did I say hydro? Automatically, you know it contains what? No, not nitrogen. The polyatomic who? Nitrate. Good, because the ick came from 8. Okay, so that's nitrate. Well, what's the formula for nitrate?
NO3.
NO3 what? 1-. Okay, so nitrate is in this compound. Well, who's the other guy in the compound? Who? No. Nitric acid has to have what element? Absolutely. Hydrogen, right. So there's our H+. It always goes in the front. Nitrate is the other piece of the puzzle. Crisscross charge, what do you get? HNO3, right. So nitric acid comes from nitrate ion. Nitrate crisscrosses with H to make HNO3. You're writing some examples down, you're just absorbing it all like a sponge? You're absorbing? Okay. I'm a writer, I'm a frantic writer. I'm the one like, hold on, I just need to write this down. So you guys scare me when you don't write anything down. That's why I keep asking. Okay, so I'm going to change the name of this again and go nitrous acid. Okay, so then when I say O's, you think ite, right? Tendinitis. So that came from who? Who's nitrate? And NO2 1-, right? Because 8 and ite is different by 1 O. That's our little trick there in the end. And then who also is in the acid? Hydrogen ion, H+, and so crisscross, what do we get? Wait, there's no 2 there. That's a 1 and a 1. HNO2. Okay, I'm going to stop for a moment. Do you see 1 through 30?
Yeah.
Okay, I want you to pick some from the 1 through 15 side and some from the 1 through 30, and I'm going to problem solve with you, but I think that if you can see the first name and last name, if you can see the first and second element, or first and second part of this, you can get the name. Try it out first. So I'm guessing we are starting on 1 through 15. So let's try to be consistent here. Start on 1 through 15. All right, so let's check the first couple together. Chloric came from chlorate. That's H plus and ClO3. That's two L's. ClO3, 1 minus, so it's HClO3. Acetic acid is HC2H3O2. With me so far?
Yes.
Okay. Hydrobromic, I'm like, oh, I see hydro. That means what? Binary, so two elements, H and Br, and they both have what charges? Ones, right? Plus 1 and negative 1. So that's going to give us HBr. Sulfurous came from sulfite. Okay, it kind of has a little bit of an extra couple letters in there, but it is sulfite. So it's H2SO3. Chlorus came from chlor. No.
Chlorate.
Not chlorate. Chlorite. Remember, tendonite, us, and ick, and 8. Okay, so that's HClO2. Hydrochloric, that's a binary one because it says hydro, so that's HCl. Okay, phosphoric acid, guys, anybody? H3PO4, good, because that 3 was crisscrossed over from phosphate. Nitrous, we already did this one, but go ahead. H and O2, good. Hydrofluoric, oh, see hydro, what do I think again? Binary, so I have to pull H and F, and they both have what charges? 1, so that's HF. Perchloric, okay, so perchloric came from perchlorate, which is what? ClO4. Okay, so that's H, 1 plus, ClO4, 1 minus, no numbers appear. Okay, so if you don't finish this up, finish this first, and then if you can bounce over here to attempt to name, try to write the names out. Okay? Mm-hmm. 1 plus, 1 minus. You just kind of like systematically think, I would look on the list from 16 to 30. I would make all the hydro ones first, like all the binary ones first, or name all the ternary ones first. So you can kind of think in like a systematic way, or you can mix them up together.
Oh,
So it's not called phosphorus. It's phosphorus. There's a trait that I told you guys in there. Kindle my book. Alright, so I know you're finishing this up, but if you have not printed your problem set and you need to grab a copy of it from online, grab a laptop now. Just so that can boot up while we finish checking these. Just converted my text. Alright, let's check through the rest of the ones that you guys have accomplished. If you've not quite finished, it's okay. There's a lot of acid practice here, so I think you'll be fine. So I'm just going to call these out loud and give me a thumbs up, okay? So 16, perchloric acid. Phosphoric acid. Notice I'm trying to enunciate the endings here. Hydrochloric acid. So this is a thumbs up, thumbs down situation here, okay? 19, sulfuric acid. 20, nitrous acid. 21, hydroiodic acid. 22, acetic acid. 23, hydrofluoric acid. 24, phosphorus. Oh, I can't really erase that very well, so I'm just going to correct it. Red. Phosphorus acid. 25, chloric acid. 26, carbonic acid. 27, sulfurous acid. 28, hypochlorous, because that's less than, no, dang it, I did that again. Sorry, that's just chlorous acid. I was watching some people off task here. So chloric, yeah, chlorous. So that's just chlorous acid. What would hypochlorous acid be? H what? Hypochlorous would be what? 1, right. HClO, HClO. And then nitric, which is one we've done before. And lastly, HBr is hydrobromic, because you've got a binary compound. Okay, so I know this is fresh. This is like right in the face. How do you feel about acid so far? All right. Just you have to classify binary. If it's binary, what do you have to say? Hydro. And if it's not binary, what do you not say? Okay, so then that's going to help you differentiate between the two. All right, so I'm going to pause for now. Go to your problem set. I'm going to call up you guys individually because I'm going to try to just give a quick scratch, like check, XX on some of your problem set ones that I know where there's always some issues. That way you can get some feedback right now, okay? So work on problem set. Some of you guys are probably closer done than others. So I will show you where else you can get some practice in on my website. And this is not a like let's Google answers because you're gonna fail every quiz, right? You want to be able to do this on your own. And I would put that polyatomic ion sheet away so it's out of you until you like absolutely need it. Steps. I got you. All right, so look up here real fast for me. Eyes up here. Problem set, you know you have access to 100%. But I gave you guys some more practice. Estes, eyes up here. So you guys have some practice here. The Quizlet nomenclature is pretty good. It mixes it up some. But then these Sporkle little quizzes, they have more thematic ones. So like you can see the first, like one is just acids, one is just covalent, one is just covalent, one is mixed. So what you can do is feel free to bounce over there once you're done with your problem set. Okay? Thank you. Let's get that thing done. You got half an hour. I got chemicals out there. If you want to, I can move some. Like this one's cleaned off over here, Wesley. This one.
These are
Thank you. Appreciate it. Are you ready? You have your last That sounds good. Yes.
So even if there's only one of them, it means it goes to zero, right?
I would encourage you to do that until you feel really good about not. Okay? You don't have to. You don't have to. But if you once people see like a lot of letters together, they don't think clearly as 1 and 2. They start trying to name everything separately. It gets messy.
No, right, but from now on.
Yeah. Well, it's okay if you're good to go and you totally understand it. Go for it. Then keep her. Or online, online. Okay. Guys, if you cannot sit next to somebody and stay on task, I'm about to move your butt. Okay? I'm going to call for a couple people to let me see the problem set so I can give you some feedback. Andrew, put your problem set. You'll be next. Riley.
CAT.
It needs to crisscross over CAH2.
Okay.
I'm just going fast if I miss something. SD's moved, Bailey moved, hand moved, Mia moved, all four of you move right now. Find a new location. So die can't go with anything ionic since we're not, you never want to die ever. Your cake goes down, you're mixing in the fancy with your like onion and your see this is not this drink acids, multiply that sentence down and it's acids. Alright, and then I'll tell you down here you're going to need Roman numerals. And then you're going to have transitionals. Thank you. Bryce?
I don't have one because I wasn't here, and then I didn't have my computer where it was, and I didn't get back
Show
to
me what you got when you get I'll done classes today. And then, Bryce, I would watch my video from Friday. That's a little while. Is he so late? Is he so late?
Ryan, because you also falls at 9.
That's what.
Oh, you're in part of it, so I can do it Friday if you're not starting.
You said watch the video.
And I'll do the next. And we were not working on anything else that we were designing. What else did you have to know? Guys, in my class, I'm sorry, you always have plenty of work, and if you don't, then I'll give you something else to do, but I'm giving you opportunity to choose how you practice. Because you have to have all your polyatomics memorized by Wednesday, I thought the practice online would be great feedback for you. You are not working on emails and homework in here.
even if it happens to be an after the basic.
Oh, I didn't.
This March last year.